Hello everyone, welcome back. Day 3 of Advent of Code. I'm recording this just moments after the last one, but I did want to keep the videos separate. I haven't figured out what schedule I'm even uploading these things on, so I'm sure this one's coming out a bit late, whatever. That way there's fewer spoilers for people who wanted to do it on their own, right? See, it's working as intended. This is the first one that I haven't looked at before putting it on video, by the way. Last one I solved on camera, but I had looked at the description earlier. Anyway, Day 3, Toboggan Trajectory. With the toboggan login problems, that's a mouthful, resolved, you set off toward the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. How nice. You make a map, your puzzle input, of the open squares and trees. Yes, looks like a roguelike to me. For example, blah, blah, blah. These aren't the only trees, though. Due to something you read about once. So nothing wrong with this sentence. It's just like English is tough because you don't know how many more words. You need like look ahead to know how to handle this word or where to put the pause in, I guess. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. You start on the open square in the top left corner and need to reach the bottom, below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3, down 1. From your starting position at the top left, check the position that is right 3 and down 1. Then right 3 and down 1 from there, and so on forever. The locations you'd check in the above example are marked here with O, yeah. Just count how many trees you would encounter. Okay. So, one thing to think about is how exactly to model this. And also how big, like how wide is our puzzle input? Not wide, it's just fairly long. Okay. So we could do the obvious thing and represent it as like a grid of booleans, basically, a list of lists of boolean. And that's okay. Lists, by the way, are horrible for this. If we cared about performance, we would use a vector or an array or a sequence or something. I guess I do have data. I do have containers. I could use a sequence if I wanted. But I think what would be quite a bit better would be to represent each row as a set of integers, representing which indices contain a tree. And then when I go to look up in a row, I'll just mod it with where I actually am, right? That's the idea. That seems okay. So let's get started on that. First, we'll get my input. Cool. That's, again, a little, like last year, a little script I wrote that downloads my input. I can't show it to you because it has my login cookie in it. But it's pretty simple. You just like load it up in Chrome, and then you look at the network tab and tell it to copy a curl request that would do the same thing, and now you can impersonate Chrome. All right. So what's the type for input? Well, import data set. Oh, you have to say qualify. You don't have to. But qualify data set as S, which is what people typically call data set, which seems fine. And our input is going to be a list of set of bool. Actually, let's say we can have set unqualified, and we'll use s dot for all the operators. Oh, you have to. That's so weird. I get it. It makes sense. The way like I kind of wish I could say import like this with most names qualified but some names unqualified on one line, but you can't do that. Like you can in Clojure. You say import this and refer these symbols. Yeah, I don't know. It seems like there's no reason why you couldn't, but whatever. So prepare is map of what are we calling our function? Read trees composed with lines, where read trees is s.from list of, well, s.from list composed with map first of filter that the second is equal to that, composed with zip with zip of like that. It type checks. Wait, what's wrong with main? It doesn't even, forget type checking. It didn't even put some parentheses in. Now does it type check? It does. No. No instance for numbool. Oh. I actually wanted to map second. No. Maybe I do. So we're zipping the whole list to number it. We got a string, and now we have a labeled string. As of this point here, we have a labeled string. And then we're filtering that the label is hash. No, I want first here, right? Why was it mad before? I don't know, I must have, this is wrong. What am I getting wrong here? Can you show me the error in more words? Here we go. First argument, yeah, okay, I guess I need to give, maybe if I just give this a type, it'll explain what's actually wrong. I want it to be a function from string to set of int. Okay. Oh, I wrote set of bool, you dummy. Set of int, okay. There you go. Now, I don't need to type on this anymore because it is correct, but I might as well. And so what we need to do with part one, again, we're using this length composed with filter hit or something. Let's just like yesterday, but I still don't think it's an important enough function to extract out unless we seem to find ourselves using it a lot. Length filter hit tree. But what we need to give it is a we need to zip it with something probably again. Yeah, let's just do that. Zip with 0, 3, like that. So we'll say we're just going to track our horizontal coordinate as we go through the forest here. And I guess we should probably uncurry hit tree. And we'll just write the hit. I assume I'll need the hit tree function for part 2 as well. So hit tree of our index, which I guess I'll call x, and then map trees. I don't want a shadow map. Even I guess I should give it a type. Hit tree function from int set of an int. I'm going to need to also know the width as well of the forest to know how to mod it. Int, I missed the arrow here. S dot member of x mod width. Okay, that type checks. Good. And we just need to say, okay, now I maybe can't write it as, because I need to know, I need to actually know the trees. Let with, I actually don't need to let that. And we'll just uncurry of hit tree length of trees, head trees. It's kind of tacky, but okay, I'll write it like this, I guess. I mean, it type checks. I'm not exactly confident that this is correct, as I might often be when writing Haskell code, because a lot of the stuff I did is pretty messy. But I'll give it a try. $95? I mean, it's a number. Nothing broke. It's not the right answer. Okay, fair enough. Hit tree length of head of trees. So it repeats indefinitely. So we started with 0. We went here and we so this should not be a hit. This should not be a hit. This should, if I understand. And then they write 0x0. It's not that there's like a tree here that we're counting that we shouldn't have. Okay. All right, well, let's start testing our stuff a little bit more carefully then. How do I get to my... Here? Okay. Interesting. I don't know what that stuff about the prompts is. Let's try writing just prepare of, you know, let's say we had dot hash and then hash dot. Yeah, it says, all right, at position 1 and at position 0 in the second row, there's a tree. All right, so parsing looks fine. Whoops. Parsing looks fine. So part 1 is wrong. So what if we wrote, I keep going to the wrong thing. What if we wrote just part 2 of that, part 1, I'm sorry, of this. we should not match on the top one, and we should on the second, right? Because that's at index... No. This tree is at index 0, and we would be at index 3, which would wrap around. So if I write this, though, we should hit it on the second go, yeah? And it's a 0. I'm saying mod 2. All right, so that's what there's something wrong with. Length of head of trees. All right, so is hit tree broken? Surely not, right? Hit tree is so simple. Hit tree of s.from list 1, let's say, of 0. That shouldn't hit, right? Oh, it needs to know the width, so we'll say 2. And I think we were actually meant to do it like this. That did not hit. Yeah. And then if we said my position is now 3, that still doesn't... What? Oh, yeah, that's fine. I was thinking this was 0. So from list of 1 means there's 1 in this position, which is position 3. So that's fine. Position 1 and position 3 and position 5 and so on. So that's all fine. And if I change this to 6, it would not hit again. So this looks fine. So the problem is in part 1. Which is a little annoying because it looks right. Let's just make sure I'm doing the math right first, and say zip 03 with this. Oh, actually, yeah, it says 0. Yeah, okay. And if we did it like this, it's still fine. 0, 1. 3, 0, yeah. All right, so that's not wrong. Something is wrong in this filter uncurry thing. Wait, I still don't know the width. Oh, length, it got me. Length is only looking at the, is looking at the size of each set, not, which is only looking at the trees, not the empty spaces. So of course that doesn't work. I forgot, I thought length was gonna... It makes sense. Length is polymorphic, and a set is lengthable, so I was getting the length of the set. I imagined I was getting the length of the original input string, but I lost that in prepare. So that's the problem. So what I need is for my input to have an int. Like this. And like this. I never know, like, the operator precedence for this stuff? Oh, not first, head. So that matches. Did I actually need the parents or not? No. Okay, that makes more sense. So in fact, in my testing, the reason I didn't detect this while I was writing these things is that I was calling hit tree and passing it a list and neglecting like how it gets the width, passing it a width and neglecting how it gets that. So if I run this again, we get 169, which is a different number. That's good news. Is it a better number? Yes. All right, let's get this stuff committed. Hello? Why can't I type? Okay, wow, it was stuck in something. Oh, did I forget to commit day 2? I did. All right, now that makes sense, right? Yeah, day 3, part 1, day 2, part 2. All right, we're good there. Now, what's part 2? Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Determining the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Okay. Okay, so we need a concept of skipping a row, which we didn't have before, which is fine. So let's define data slope equals slope of down and right, which are both ints. And so what we really want is a tree count that takes a slope and a set of trees, right? A slope and an input. So tree count takes a, I guess input first makes more sense, and a slope and it gives you back an int. Tree count of width. I guess I could have this be, I gotta this handle the be take the parts of the input separately, but I don't know, that seems kind of dumb. Width forest, and then we take a slope of B and R, and then a, what do we take last? Nothing, equals something. And we're going to do something very similar to this, where we just have to figure out how to drop every other if, like there's a function for this enclosure called take nth, which gives you the nth item, every nth item of the input list, which is what I want here. Haskell every nth element. How to get every nth element of a list in Haskell. There's nothing fancy, they're just implementing using drop. Yeah, and then stuff using yeah, okay, there's really nothing fancier than drop, huh? Alright. Fine. Well, let's write take nth, I guess. Oh, we'll make it be part of tree count, why not? And then we can just use this, right? Like the entire thing exactly. Take nth d, put an r here. Where take nth of n equals nothing. I mean, we're yeah, that's fine. Take nth n x more x's, I guess, equals x cons to take nth of n of drop n x's. So part 1 is just then tree count of oh, that's actually really easy. Part n is tree count of we have to flip it, huh? No. Yeah, flip tree count. We'll do it. We'll section it. Very fancy. Tree count of slope 1, 3. All right. What are you mad about? You don't like this? Redundant bracket? Oh, I always get... I mean, you're right. It makes me a little uncomfortable to remove these parentheses, though. I'm leaving them in. Screw you, HLint. Okay, so let's confirm that this still works. Oh my gosh. There we go. We got 48. Is that what I put in before? No. My puzzle answer was 169. Okay, well, we broke things. That's fine. Did I destructure the slope wrong? Yes, I... No, I got it right. What went wrong here? Length of filter, zip 0r. Okay, maybe take nth is wrong? It looks manifestly correct. Let's move it to the top level so I can actually test it, like I should have done to begin with. Why am I writing X? A is way more normal. So take nth of 3 on 1 to 10. 1, 5, 9? Holy shit, I wrote this function wrong. What? Oh! Because I dropped 1 implicitly by taking this X. And then 1 more, okay. So what I should have written is x is as x to anything. I could also subtract 1 from n here. I'd rather write this function without any subtraction. This is slower, but like it's fine. All right, now I get back 169, my original solution. Got it. And so part 2 is, what am I supposed to do? Multiply together the number of trees on each of the listed slopes. So part 2 is product of map I guess I wrote tree count backwards, huh? It may take its parameters in the order I thought would be useful, and it was not at all. Wait. No, this time it's right. Okay, whatever. Is it? Yeah. I don't know, we'll call it, yeah, inputs, whatever. We'll just call it I. Map of tree count I over our list of slopes. Slope of one, slope of, this is such a weird notation for lists, but that's just like the Haskell style, so I'm following along. Oh, it has to specify right first? Oh, I'm so bad. Now I have to switch all of these if I want it to look more like the problem statement, which I do. Okay, there we go. Slope 3, 1. Slope 5, 1. Slope 7, 1. Slope 1, 2. Yes, I do indeed want this to return an int. All right, it compiles. That's a very large number. Could be correct, who knows? We're multiplying together 5 numbers that each had about 3 digits. So it sort of makes sense that we would end up with this number, right? Yeah, it's close enough. That's the right answer. Great. Okay. Well, let's get it committed then. Day 3, part 2. Really? I hope we don't have any people with really sharp ears who can pick out a password by the way I'm typing it. You could probably tell them how many characters it has, I guess. I'd rather you didn't figure it out, but whatever. It's long enough. I'm okay with it being secure. Okay, that's it for Advent of Code Day 3. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.